Okay, here we are on chapter 2 on the integers, and this is section 2.2, adding integers. So with this, we're going to look at vectors, and these are basically mathematical objects that possess two important quantities. They have a magnitude or a length, and so if a is an integer, then the absolute value of a gives that magnitude or length. Okay, so we've seen what absolute value does, and so the magnitude or length is what the absolute value is, and it also has a direction. So it's going to point to the right if it's positive, and it's going to point to the left if it's a negative. Okay, so what we want to do is we want to kind of add these using vectors. And we've kind of done that before, but now we're going to actually label them as vectors here. So what we have is we want to take 7 plus 4. So what do we know about 7 and 4? Well, they're both positive numbers. So if we're going to add those together, we can start over here at 0. And then we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so we can go 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and so what we're going to do is add them with vectors. So basically, we're going to draw those lines above the numbers again. And so we'll do a vector of length 7. All right, so a vector of length 7, that will give us this. Okay, so if we think about that, we're going to take the absolute value of 7. That's equal to 7, and that's how far we go across here to this. Okay, so that's how we do that. Now what we're going to do is we were going to add to that a vector of 4. So then we have to go, okay, well, if that's where we're starting now, we add a vector of 4. That's 1, 2, 3, 4. And so that's where we're going to stop. So this is absolute value of 4, which has a magnitude of 4, or a length of 4. And so now we've taken 7 plus 4, and that gives us, we're at 11. And so that equals 11. All right, so that works for positives. We've done that before. Now what's going to be different is now we're going to add two negatives together. Now, with negatives, things we can do. We can do what we did here, take an absolute value of that value, and we get a magnitude. Absolute value of that, we'll get a magnitude. But what happens is we know we're going to the left. So we can't say we're always going to draw to the right, because what happens is we're going to take the absolute value of negative 7 plus the absolute value of a negative 4. Well, this is 7. This is still plus, and this is 4. And so we get 11, but what happens is we take the sign that's common to both of those. So it has to have the same sign to make this work, adding two integers together. And so we get the two magnitudes, which is 11, but now we have to take that sign. And so now the actual answer is a negative 11. And so what we're going to do now is, now we know we're taking and going a negative 7 direction. We'll start over here at 0 and then go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so we'll go negative 1, negative 3, negative 5, negative 7, negative 9, negative 11. Okay, that way I don't have to write all those negatives in there. Now, we're going to go left 7. So that's basically what we're saying here. We're going to go left 7. So we start here and we go left 7 because we're going negative 7. And so, like I said before, the absolute value of that negative 7 is 7 units, kind of like in 2.1. If we turned left and we went 7 blocks, we're going negative on an XY axis, or an X axis here, but we actually go a distance of 7 blocks, and that's kind of what we have here. And now we go negative 4 more, so we go 1, 2, 3, 4, and we get to that point. And so this is our value, and then we had the negative 4 absolute value that was equal to 4. And so like I said, we're taking the 4 plus the 7, we got our 11, but we took a left turn. Because we took a left turn, we're going the negative direction, and so we have to keep that negative value with it, and so our answer then is negative 11. And so this is kind of what that leads into. Adding two negative numbers or two integers together, we add the magnitudes, what we did here on this last one. Oops, the last one here, we added the magnitudes. We took absolute values and got 7 and 4. And then we prefix the common negative sign to that answer. And that's what we just did. So if we think about that, now we have a -5 plus a -8. Well, if we take the absolute value of both of those, we'll end up with 5 in this case and 8 in this case, because if you think about that, we've gone 5 and that distance is 5 blocks. We took a left turn to get a negative sign, but it's 5 blocks, and then we're going to add to that 8 more blocks. And so, even though it's the distance is 8 blocks, it's represented by that -8 because we're going in the left direction. And so we took and added the two together, 5 plus 8, and we get the 13, and then we prefix the common negative sign with the final answer. So we had a negative and a negative, so we put a negative on that 13. Okay, and so this kind of shows what we were doing in the previous one in kind of a little bit more detail and kind of saying what we're really doing with these. All right, so what about the next one? Well, this one, it says we are going to take a -8 and then we're going to add 4. Now, if we think about that, let's say we're going to go left first. We're going to take that left turn. Here's our 0. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's go by 2. So -2, -4, -6, -8. So we're going to go and take a left turn and go a distance of 8 blocks or 8 spaces. So we've gone here this 8, and so that's the absolute value of -8 is equal to 8. So we know we've gone the right amount this way. And then we're going to add 4 to it. Well, now this time we're adding 4, which is a positive, so that means we have to turn around and go the other direction. So now we want to go to the positive direction. We want to go this way to the right. And so we're going to start here at 8, and I'm going to put it below because we're going the other direction. And now we go 4 spaces. That's probably going to get rid of it. Maybe not. Now we're going to go 4 spaces this direction. Okay, I did get rid of it. And so that was absolute value of 4 is equal to 4. And so we've gone 4 spaces this way. And so our answer then is that -4. Okay, so we're kind of doing, like we did with adding and subtracting. We go this way one way, and then we go back the other way. And that's what we've done. We've gone 8 blocks to the left, and now we want to go 4 blocks to the right, and that takes us to our -4. And so our answer is -4. Now, the thing with this one to note is what I would say an easy way to do it would be like when we add two negatives, we do this. When we have opposites, what I would do is I would take the larger one, subtract off the smaller one, and then put the sign of the larger one back on. And that's what we've done here. We take 8 minus 4 is 4. The larger one is negative, and we get the negative. And so that kind of shows you how that works. And so this is kind of what we led into here, adding two integers with unlike signs. We subtract the smaller magnitude from the larger magnitude, and then we prefix the answer with the sign of the larger magnitude. And that's what that's saying here. So we're taking the larger one, the magnitude was 8, subtracting off the other one, which was the magnitude of 4, so 8 minus 4 was 4, and then we prefix it with the sign of the larger, which was -4. So now let's go through a couple examples here. And these look to be all opposite signs. We're adding two integers with unlike signs. And so what we're going to do is we're going to think about it. So absolute value of 7 is 7. Absolute value of -10 is 10. So the larger magnitude is 10. So what we're going to do is we're going to take 10 minus 7. That gives us a 3. Now the larger magnitude had a negative sign, so our answer is going to be a -3. Okay, so that's how that one will work. And similarly, we have the same thing here. So we'll take the absolute value of a -12, and that's equal to 12. And we'll have the absolute value of 16. That's equal to 16. So the larger is 16, so we'll take 16 minus 12. Well, 6 minus 2 is 4, and we get that. And so our answer is going to be 4, and our sign, well, the larger sign was positive, so that means that's going to be our answer. Okay. Now the same thing goes here. Now let's not go ahead and write out the absolute value. Let's just think about this with just numbers. So we know the absolute value that's going to just be 125, and absolute value that's going to be 110. Which is bigger? Well, 125 is bigger. So we'll subtract off the smaller. So 5 minus 0 is 5, 2 minus 1 is 1. And so we get 15 as the magnitude, but what's our sign? Our sign is going to be negative because that was the larger magnitude prior to taking that absolute value. So that would give us a negative 15 for the answer. All right, so we have similar properties here with integers as we did with whole numbers. And the only thing that changes is we're letting the A and B or C, we're letting them be integers. So we're going to have the commutative property of addition. And A and B are integers. So then we can say, well, we can take A plus B, and that's the same thing as B plus A. And you'll notice this as we move through the book, a lot of this stuff is the same each section or each chapter, and the only thing that changes is what are our numbers, basically whole numbers, integers. We'll go to rational numbers. We'll have all kinds of things, and we're going to have these same properties. And so basically what we're going to say is those properties work for any kind of number as long as we're doing addition or whatever. So that was the commutative property. We can change order. Now, the associative property of addition, again, we're letting A, B, and C be integers. Then we can associate the first two, A and B, and then add C later. Or we can associate B and C and then add the A later. And both ways we do that, we're going to get the same answer. Now here we have the additive identity property. So the whole number 0 is called the additive identity. So if A is any integer, positive or negative, if we take A plus 0, we get that A back out. So if we think about that, if we take 2 plus 0, we get 2. And if we take a minus 4 plus 0, we get a minus 4. So no matter if we have a positive or negative A, we get back the same value. Now we have the additive inverse property. So now this is a little different because here now we have this unique integer called the opposite of A or negative A. And so we're going to let A be an integer. Then the unique integer negative A, also called the opposite or the additive inverse of A, says if we take A plus the opposite of A, that's equal to 0. Or if we take the opposite of A plus A, that's equal to 0. Okay, and if we think about that numerically, if say we take 2 plus a negative 2, well, that's going to be 0 because that's 2 minus 2, which is 0. And we could do this the same thing either way. It doesn't matter if we add them in order because, again, we have the commutative property of addition. Now, what we can do is we can group things for efficiency. So we're going to see problems that have lots of things we have to add together. And so if we group for efficiency, that's going to help us a lot. So normally we work from left to right with the commutative and associative properties. We can actually change and rearrange the problem to make it work easier. All right. So here we have a number, an expression that we're supposed to simplify. So minus 8 plus 9 plus negative 4 plus 2. Now here, note that we say a plus a negative 4. We don't say plus minus 4. That's not a correct thing. So we're never going to say the 9 plus minus 4. We're not going to do that. That's out. We're going to say 9 plus the opposite of 4 and put that in parentheses like that. So that's going to be the key thing that we need to remember is you don't put a plus minus right beside each other. All right, so we're going to do this two ways. We're going to do it the old way where we go from left to right, okay? So when we do that, we'll have a negative 8 plus 9 plus the opposite of 4 plus 2. So we'll do those two first, okay? Minus 8 plus 9. Well, that's just 9 minus 8, which is 1. Then we still have plus the opposite of 4 plus 2. Now we do the next two. 1 plus a negative 4. Well, if we do what we learned here, we're going to take the larger minus the smaller. So 4 minus 1 is 3. The sign of the larger is negative, so that's going to be a minus 3. And then we still have plus 2. Now here we have a minus 3 plus 2, so we end up when we get that, that's equal to a negative 1. Now, what we're going to do here with rearranging is we're going to say, well, let's say we have, again, negative 8 plus 9 plus the negative 4 plus the 2. Let's put these two together, and let's put these two together. So we'll have one step here, one step here. We'll get two numbers, and then we can just add those directly. And what happens is, then we have the same sign on both of them, so we can add the two numbers and put that same sign. And so a -8 plus a -4, well, 8 plus 4 is 12, and the sign associated with it is negative. And here we have 9 plus 2, and that's 11, so we have plus 11. Now minus 12 plus 11 is a -1. So we get the same answer both ways. But if you notice, we did this here and got the, if we want to write it above, that's a -12, that's 11, so we know where we got those. And so then we could rewrite it here, and we get it in basically that one step after that. Here, we had to do one step, and then another step, and then another step, and got that. And so it kind of looks like it is done quicker here, and so that's why rearranging sometimes makes things more efficient. All right, so I'll pause there and I'll go do another part in a second.